Section 5.5, we're going to start out with double angle formulas. Let's start with the angle sum formula for sine. We have sine of alpha plus beta is sine cosine and then cosine sine. Well, what if we change that to the same angle? So let's say theta plus theta. That would be sine of theta, cosine of theta, and then plus cosine of theta, sine of theta. And then we could write sine of 2 theta is equal to, now these are exactly the same, we could have 2 sine of theta cosine of theta. And that's the first formula that you need to know. Let's do the same thing with cosine. We could have cosine of theta plus theta, and that would be cosine of theta minus sine of theta, sine of theta. And we have cosine of 2 theta is equal to cosine squared theta minus sine squared theta. And because these are squared, there's 2 more that we can write for cosine. We can say that cosine squared is 1 minus sine squared. So we'd have 1 minus sine squared theta and then minus sine squared theta. Changing the cosine squared to 1 minus sine squared gives us 1 minus 2 sine squared theta. So cosine of 2 theta can also be written as 1 minus 2 sine squared theta. And then doing the same thing with sine squared, we have cosine squared minus 1 minus cosine squared. And so we have 2 cosine squared theta minus 1. So this is equal to 2 cosine squared theta minus 1. Let's do the exact same thing with tangent. We could have tangent of theta plus theta, and that is tangent of 2 theta. And if these are going to be exactly the same, then we have 2 tangent of theta on top, and then if both of these are thetas, then in the denominator we'd have 1 minus tangent squared theta. If sine of theta equals negative 7/25 on the interval pi to 3 pi over 2, in other words the third quadrant, find the sine of 2 theta, cosine 2 theta, and tangent of 2 theta. Well, we have sine squared, 49 over 625, plus cosine squared theta is equal to 1. So cosine squared theta is equal to 625 minus 49 is 576. So 576 over 625. And then cosine, now if you take the square root of both sides, is going to be negative 24 over 25. And it's negative because we're in the third quadrant. Now that we have sine and cosine, we can find the double angles. Sine of 2 theta is equal to 2 sine of theta cosine of theta, and we know those values, so we have 2 times. The sine of theta is negative 7/25, and cosine is negative 24/25. So when you multiply the tops, multiply the bottoms, you get 336 over 625. The cosine of 2 theta is equal to, we can choose between 3 of them. We can do cosine squared, which we found, that's 576 over 625, minus sine squared theta, which is 49 over 625 actually. And 576 minus 49 is 527 over 625. Now to find the tangent of 2 theta, I'm not actually going to use the formula. Let's just use sine of 2 theta over cosine of 2 theta, which is 336 over 625 over, there's the sine, over cosine, which is 527 over 625, which is equal to 336 over 527. Solve sine of 2 theta minus sine theta equals 0 on the interval from 0 to 2 pi. Well, sine of 2 pi can be written as 2 sine theta cosine theta minus sine of theta equals 0. And now we can factor out a sine. And that's 2 cosine minus 1. Sine of theta is equal to 0, and that happens at 0 and pi. And then for the other one, we have cosine of theta equals 1/2, and that happens at pi over 3 and 5 pi over 3. Here we have cosine of 2 alpha equals negative sine squared alpha. There are 3 ways to write cosine 2 alpha. Let's choose 1 minus 2 sine squared alpha equals, and then negative sine squared alpha. If we add 1 over, we have 1 equals sine squared alpha. And so sine of alpha is equal to plus or minus 1. So alpha is equal to pi over 2 and 3 pi over 2. Solve tangent of 2 beta equals 2 tangent of beta. Well, the double angle formula for tangent is 2 tangent of beta over 1 minus tangent squared beta, and that's equal to 2 tangent of beta. Now we can multiply both sides by 1 minus tangent squared, and we have 2 tangent of beta equals 2 tangent of beta, and then times 1 minus tangent squared beta. Then we can divide both sides by 2 tangent beta, and we get 1 equals 1 minus tangent squared beta. Subtract 1 from both sides, we get negative tangent squared beta, and then tangent squared beta is equal to 0, and when you square root, you get 0 also. So beta is equal to 0 and pi. Let's talk about power reducing formulas. With cosine, here's one choice, but we have 2 others. We can write cosine of 2 theta is equal to, we could do 1 minus 2 sine squared theta, and then how about minus 1? Let's get sine squared by itself. That's equal to negative 2 sine squared theta. And then when we divide by negative 2, we can write sine squared theta is equal to 1 minus cosine of 2 theta over 2. When we divide by the negative, that turns this around, and then it's over 2. So we can turn a power of 2 into a power of 1. That's why we call it a power reducing formula. We can also say that cosine of 2 theta is equal to 2 cosine squared theta minus 1. So we can add 1. Cosine of 2 theta plus 1 equals 2 cosine squared theta. And then we have cosine squared theta is equal to, we can write 1 plus cosine of 2 theta all over 2. So the sine will be minus and the cosine will be plus. And we can turn cosine squared into cosine of 2 theta with some extra stuff here. Rewrite sine to the 4th x in terms with no power greater than 1. Well, we can write this as sine squared x times sine squared x. And then we can replace sine squared with 1 minus cosine of 2 theta over 2 times 1 minus cosine of 2 theta over 2 also again. Now when we square these, we get 1 minus 2 cosine of 2 theta plus cosine squared of 2 theta, and then that will all be over 4. Well, if cosine squared theta is equal to 1 plus cosine 2 theta over 2, then if we put a 2 here, we're doubling the theta, then we'll double this, and that'll be a 4. So we can write this as 1 minus 2 cosine of 2 theta, and then plus 1 plus cosine of 4 theta, and then over 2. And that is all over 4. We can get rid of the complex fraction by multiplying everybody by 2. We get 2 minus 2 cosine of 2 theta plus 1 plus cosine of 4 theta, and that's going to be all over 8 now, because remember we're multiplying everybody by 2. So the final answer is 3 minus 2 cosine of 2 theta plus cosine of 4 theta, and that's all over 8. Rewrite each expression in terms with no power greater than 1. Here we have cosine squared of x times cosine squared x, and that's going to be equal to, let's do that in the later notes, the next day. Let's get rid of that. Rewrite each expression in terms of no power. Let's get rid of that one. Let's bump this up. Solve an equation using a power-reducing identity. Here we have cosine squared x, and we can write that as 1 plus cosine of 2x all over 2 minus cosine of 2x equals 1/2. And then we have 1/2 plus 1/2 cosine of 2x minus cosine of 2x equals 1/2. Now we can have, 1/2 minus 1, that's negative 1/2. Cosine of 2x is equal to 0. Cosine of 2x is equal to 0. And then 2x would be equal to inverse cosine of 0. So 2x would be, inverse cosine of 0, that's pi over 2. And on one trip around, 3 pi over 2. But then when you divide by 2, you get pi over 4 and 3 pi over 4.